Okay, so I'm going to go through question 1 of exercise 5C to kind of get you started. So let's have a look. We are asked to use the unit circle to complete the following table. So by now we should be comfortable converting between radians and degrees and the other way around. And some of these angles are angles that come up over and over again, so they should start becoming second nature to you. So let's start off with our first one. So 0 degrees, we know that 0 degrees is at the positive axis, so this x-axis, so that's 0 degrees. We can see that at 0 degrees that the number of radians would be 0 because 0 radii have covered that part of the arc length. We go to 90 degrees, so in radians, 90 degrees, we move up 90 degrees to here, and we know that 90 degrees can be written as pi on 2. Then 180 degrees, which is over here on the straight line, we know that's going to be pi radians. 270 degrees, we know that it's going to be 3 pi on 2 radians, so 1.5 revolutions. Then 360 degrees would be 1 full revolution, so we come back to our initial position, which is 2 pi. And then finally 450 degrees is going to be 5 pi on 2. Now let's just consider why this would be 5 pi on 2. So 450 degrees, if you consider the unit circle from 360 degrees, which is at this point here, we've added another 90 degrees. So let's consider what's actually happened. So we were at pi on 2, but we've done a full revolution. So we need to add 2 pi. Now, if I add 2 pi to pi on 2, well, 2 pi can be written as 4 pi over 2 if I multiply top and bottom by 2, which is 5 pi over 2. Okay, and you can see from yesterday's video that if I add 2 pi to any coordinate or any angle, then I'm going to end up in the same position on the unit circle. So now let's consider the sine and cosine values of each of these. So at 0 radians, we know that our cosine value is going to be 1 and our sine value is going to be 0. Then at pi on 2, we can see we've got a cosine value of 0 and a sine value of 1. At pi, we've got a cosine value of -1 and a sine value of 0. At 3 pi on 2, and you can start to think about these without even looking at the unit circle, because if I look at 3 pi on 2, well, we know that in terms of x position, it hasn't moved off of the axis, and then in terms of the y, it's going to be at -1. So you can see it's going to be 0, -1. For 360, we're back at the position of 0, which is 1, 0, and then finally for 450, we're back at where we were for pi on 2. So our x coordinate is 0, or cosine is 0, and our y coordinate is 1. Now our tangent, remember the tangent function, excuse me, is defined as our sine function over our cos function. So let's have a look. If I've got 0 over 1, this one, 0 divided by 1 is 0. What about 1 divided by 0 for 90 degrees or pi on 2? Well, can I divide anything by 0? No, which means that the tangent is going to be undefined. And remember, we could think about it of the slope of these radii. So at 90 degrees, we can see that the slope would be vertical, therefore it would be undefined. At 180, it's going to be 0 divided by -1, which is 0. At 270, it's going to be undefined again. At 360, it's going to be 0. And then finally at 450 degrees, or 5 pi on 2, which was that pi on 2 plus 2 pi, we know that it's just going to be undefined again. Okay, in question 2, we're asked to state the exact coordinates of A, B, and C in terms of sine and cosine. So I'll start you off with 2A, and then I'll leave you to do B. So in 2A, if I'm looking at this first position of 26 and I want to know the exact coordinates of point A, so I know that A, the x coordinate is going to be cos of 26, and my y coordinate is going to be sine of 26. Then I can move to my next coordinate B, which is going to be cos of 146 and sine 146, and then finally point C, which is at an angle of 199. We know it's going to be cos of 199 sine of 199. So those are the exact coordinates. Then in part B, if we're asked to use our calculator to find them correct to 3 significant figures, so you need to grab your calculator. Okay, so in our calculator, we're going to go to math mode. And the first thing that we need to check is, because we're trying to write each of these exact values in terms of converting them into a decimal value, all of these are given in degrees. So if these values were given in radians rather than degrees, then there's a certain setting on the calculator we need to use. But because they're all in degrees, let's check our setup. So you can see above menu is in yellow, it says setup. So if I click the shift to get to the yellow, and then I'll have to come down and I have to change this to degrees in this scenario. So then for point A, I'm interested in cos of 26 and sine of 26. So these values are going to be cos of 26, and we need to round to 3 significant figures. So it's 0.899 for the cos, and then for our sine value, it's going to be 0.438. Then for our next coordinate, we have cos of 146 and sine of 146. So you can see that we've got minus 0.829. And then for our sine coordinate, we've got 0.559. And then finally, point C, we've got cos of 199 and sine of 199. So cos of 199 is negative 0.944. Now, because this is a 5, that's going to have to be rounded to a 6. We have to write it correct to 3 significant figures. And then this one here is going to be minus 0.326. Okay, now this is going to be the last question I'll work through with you, and then you should be in a good position to continue working through the remainder of the questions. So in 3A, you're asked to use your calculator to evaluate these two values. Now, they're not two random values. If we remember our unit circle, 1 over square root of 2 and square root of 3 over 2, of values that come up very often around the different coordinates on the circumference of the unit circle. So have a look at what this is in exact form, so have a look at what the estimated values for these two would be. Then in B, we have this table, so these values should look familiar to you. We know that 30, and these are values that we use over and over again, so you should notice straight away that 30 degrees relates to pi over 6, and then you can look at 45 degrees, and we know that 45 degrees is going to be pi over 4, then 60 degrees is pi over 6, then 135 degrees is 3 pi over 4, and so on. So use this unit circle to familiarize yourself with some of these key angles which we use over and over again, and then record the sine and cosine values for each of those angles and begin to familiarize yourself. It is important that you can recall these different values around the unit circle, and within the test, if we were to have a test on this topic, I would expect you to be able to recall those values without having a unit circle in front of you. So spend some time learning each of those different angles and the corresponding coordinates. Okay, that is going to be the last question that I worked through with you. Question 4, we did that small little investigation in yesterday's lesson, so you should be fine working through that. And then there's just a few questions to do with those revolutions and what it might mean for the sine and cosine and tan values of each of those angles. So have a go at those, and I'll see you in our next lesson.